Hello friends, we are now employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do longest repeating character replacement lead code problem that contains very important properties related to string based problems. If we see the companies where I want to get a job and that have already asked this question, there are companies like Google, Amazon, Uber, Adobe, Facebook, Apple, Bloomberg and Microsoft. So some of the top tier IT companies. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we are given a string s and we are given an integer k. Now we are told that inside this given string s, we can replace any character with any other character in the English language, and we can repeat this operation k times. Now, after repeating this operation, what is the main purpose of this question is that we need to return the length of the longest substring that contains the same letter by doing this replace activity, and we need to return that length. Okay, so now we will try to understand this problem with this example. So suppose we are given our s is equal to a, b, a, b. And we are told that k is equal to 2, which means we can replace any two character with whatever two characters we want. So in this case, we have two options. Either we replace these two b's with value number a, then we will get a string that looks like a, or we can replace these two a's with the letter b, and then we will get a string. Our concern is we don't care what is the value of the string. Our aim is to find the longest substring that contains all the repeated character, and we need to find the length of it. In both the cases, the length of these two is actually 4, and this would be the answer we need to return. So this is what the problem is asking us to do. Let's take one more example to make our understanding more clear. So suppose our given s is equal to hp. If this is the case, and our given k is equal to 2 again in this case. So now if we see the options we have, we can replace like these two p's with the value h. So that will give us a string like h. And so if we see the longest substring that contains the same letter, the length in this case becomes 5. Second option we have is that we choose any two h value, suppose these two, and we replace it with value number b. If we do that, we will get a substring that looks like this. So in this case, if we see that what is the longest length of the subsequence that contains the same letter, it's actually 4. So this is 4 and this is 5, and we need to return the longest. So that's why this is the most optimal way to approach this problem in this case, where we are going to replace these two p values with the letter h, and we don't do this p operation. So there are few ways to solve this problem, and there is also a brute force way to solve this problem. So first I'll show you the brute force way, and then we will see that what would be the optimized approach. First of all, we identify that what is the thing that we want to find. We want to find a substring, and then we want to replace the characters, and then we want to find a substring that contains the longest length with the same characters, right? So first approach we can take in the brute force is that we take every single substring that is possible. So even if we just see that substrings that starts at a, we will get substrings like a, b, and a, something like this. Again, if we see substring that starts with b, we will get b, a, and so on and so forth. So we would end up with bunch of different substrings. Then we will start this replace operation on all the substrings, and eventually we would find some substring that will look like this a, or this b. And in any case, we would be able to return the length as 4. Like, okay, this solution would work and we will get the desired result, but there are a lot of issues with that. Even if we just see that for a single character, we end up with like so many substrings, and we still have more substrings to go to. So this is a very inefficient approach, and we should avoid doing it at all costs. Okay. Before we come up with the optimal solution, first of all, we will have to identify that what is our need. Our need in this case is that we are given this string, and we are told that we can replace any two characters inside this given string with any other characters because k is equal to 2. Now we need to find a substring where all the characters contains the same value, and because they contains the same value, we need to return the length of it. So first of all, we will have to identify that what is the substring where we can actually create all the characters of the same length. So first of all, let's see that can we apply this thing on this whole substring for this entire string of all the 5 characters, and this given k is equal to 2. So first of all, we will try to identify that what is the number of occurrences of every single character. So a occurs 2 times, b occurs once, c occurs once, and d also occurs 1. So which means that because a occurs most of the time, our logical or rational conclusion is to create a substring where all the characters are A, because in that case we will actually have one additional character. If we try to create all the characters with with value B, C or D, obviously we are always going to fall short by one character, because the value of A actually appears twice, which means these three things, they have less significance compared to this A, because A is the most repeating character. And why I'm putting so much emphasis on most repeating character, because this along with this K and the length of the string or substring defines that whether any substring we can convert it to all the repeating characters or not. Let me show you how. Suppose in this case we consider all these 5 characters. Even if we replace any 2 characters, in this case we have 3 characters to replace from. If we replace any 2 characters, no matter what happens, we won't be able to create a substring where all the 5 values are actually A. Why? Because we only have the option to replace 2 elements, and there are 3 different elements that contains different values. So how we come up with this value that there are 3 different elements that contains different value than A? Well, what we did was we took the length. So length in this case for this substring is 5. So we took the length of this substring minus, we subtracted the most occurred character. So most occurred character in this case is A. So length 5 minus A 2, and this we get 3. So at any case, this value, if that is greater than or equal to this value number K, which means that this particular substring we cannot do anything about it. We cannot convert into a valid or legitimate substring where all the values contains the same character. But if we just shorten our search, if we try to search in these 4 characters, okay, now what is the breakdown of the number of occurrences of every single character? Well, A still occurs twice, B occurs once, C occurs once, but D is not appearing, so we ignore this one. Now in this case, the length of this is equal actually 4, which means that if we apply the same formula, that length minus whatever the maximum occurred value, so maximum occurred value is still A, which means that we do 4 minus 2. So 4 minus 2 is 2, and this 2 is actually equal to whatever the value of K is. Because this is equal to K, and in this case we can define that for this particular substring we can actually convert it to all the characters being same by using this replace function. And if we just replace this value B and C, we will get actually a substring that is all the A's, and this is the answer. So basically this is the critical part. Now remember that in order to generate this, what are the things we needed? We actually needed that what is the current length of the subsequence that we are following, or what is the length of the substring that we are doing. We actually need to know that what is the maximum occurrence of any particular character in any given subsequence. And we also needed that what is the value of K. Based on it, we were able to identify that whether any subsequence can it be converted to having all the characters to have the same value or not. And based on this concept, so formula we can create is that a valid subsequence is a subsequence where the length of the subsequence minus the most occurred character. If this one is actually less than or equal to whatever the value of K is, if this is true, then we can say that this is a valid substring, and the length, whatever the length of this particular substring is, that is also the length of the substring which contains the most repeated characters. Let's see it with an example. Okay, suppose this is the example that we are given and we want to solve this one. First of all, we are going to see that what is the formula that we have to use. Well, the formula we have to use is that for any subsequent to be valid, what we are going to do is we are going to do length minus whatever the max occurrence in that particular subsequence, and we will see that if that value, if that is less than or equal to K, if that is less than or equal to K, whatever the length is, we can treat it as our answer, and whatever the maximum answer we find so far, we will conclude it as our solution. We already know this formula. Now we need to see that how can we implement that. Basically we are going to use a sliding window plus 2 pointer solution. And inside this solution, what we are going to do is we are going to have 2 variables called left and right to be initialized at the first position. We are going to update the right value to the next element. Then we will check that whether the substring is valid or not. If the substring is valid, we will calculate that what is the answer. We will update the answer. again we will move the right value, and again we will move the right value, again we will move the right value until the point when the substring is not valid. The moment the substring is not valid, we can conclude that now we need to shrink our substring. So basically, suppose the R is now at this position, we will have to update the value of left. So we will ignore this element and we will move our left value over here, and then subsequently we will keep moving on, and every single time we will keep track that what is the maximum answer we have found so far, which is the longest repeated character substring, the length of it. And whenever the R reaches at the end of the list or at the end of this string, we can conclude that whatever the value we have stored in the answer, we can return it as the answer. So now, because we are using this two pointer approach, we know that at any given moment, what are the things we need? Well, we need a couple of things. First thing we need is we need this length. So length we can identify based on the difference between this left pointer and right pointer. That gives us the length of the current substring. Now we need to know that what is the maximum occurrence at any given moment of any particular element. So we don't know that, right? So what we can do is we can actually create an array of size 26. So one for every single character in the English language, because we know that there are only 26 characters. And whenever we find any value on the right side, we will add that value to our array. Or if we move any character on the left side, we will reduce that value from our array. So at any given moment, we would always know that what is the maximum value we have at any given position. And let's see by an example that how we will complete this operation. So let me quickly show you an example that how we will iterate over for this given example. Let me clean this up a bit. Okay, so initially our left value and right value are located at these two positions. We are also going to have an array to store the maximum occurrence of any single element. So currently I'm just showing you the elements that are coming in, but that is the idea that we will keep in mind. So first of all, currently the value is p. So we will add p over here, and we will notice that okay, the occurrence of p is one time. Just this is for understanding purposes. When we do the code, it would be slightly different, and I will explain it to you when we would be coding. Now so far this list has to be valid because there is only one character, right? Now we will update the value for r. So this is x, and x is also present one times. Now we will see, so current length of this string. So now r is located over here. Okay, so current length is actually 2. And what is the k value? K value is also 2 because that is constant, so that won't change. And what is the maximum occurrence of any character so far? So maximum occurrence is still 1, as we can see over here. So maximum occurrence is 1. So if we apply this formula, 2 minus 1, so 2 minus 1 is actually 1, and 1 is less than or equal to value of k, so that is true. So because this is true, we can say that the length of at least 2 characters can be part of the answer. So we will mention that in the answer. Now again we will update the value of r. So now r comes over here. Because r comes over here, we will update the value of q over here, and we know that it occurs one time again. So the length, so the current length is actually 3, and the maximum character is still 1. So we will do 3 minus 1. So 3 minus 1 is again 2. 2 is still less than or equal to value of k. So this is also true. Because this is true, the current length can be part of the answer. So we will update our answer to have the value 3. Now we will again update the value of our r. So now r will go over here, and this is x. So for x value, we already have 1 as its occurrence. Now x has the occurrence 2 times. So we will update the occurrence of maximum number over here called 2 times. The length also increases, so length will become 4. Now again we will try to see that what happens with our equation. So we will do 4 minus 2. So 4 minus 2, this is 2. 2 is still less than or equal to k, which is 2, which means that we can update the answer to the value 4. We will update the answer to be 4. Now again we will update the value of our r. Now r moves one value to the right. Now this is y. Y is occurring 1 times. Now the current length is 5, and the maximum value we have is x, which is 2. So far we are good. Now we will try to do 5 minus 2. So 5 minus 2 is actually 3, which is greater than k, which means that this condition is not satisfied. So because this condition is not satisfied, what we need to do is we need to update the left element. So we will update the left element over here. So now left comes at this place, but because we are updating the left element, we will also have to remove this 1p over here. So we will remove p from here, and now we will update the value. So now length will become 4. Again, maximum occurrence is still 2, so 4 minus 2, that is 2. 2 is still less than or equal to k, which is good. So far we are good. Now again we will update the value of our r. So now r comes at this place. Because r comes at this place, the occurrence of x comes to 3. Now because this comes to 3, we will update the value of maximum occurrence to be 3, and we will update the length to be 5. Now we'll do 5 minus 3. 5 minus 3 is 2. 2 is still less than or equal to k. So because 2 is still less than or equal to k, we can update our answer as well to the whatever length we have found, which is 5. So we will update our answer to be 5. Now again we will update the value of our r. R comes over here. Now this is a we don't have any entry, so we will add an entry for a and we will call it as 1. Now in this case the length is 6. Length is 6, but maximum number of occurrence of x is still 3, which means that now we can do is 6 minus 3. So if we do 6 minus 3, 6 minus 3 is equal to 3. 3x is actually greater than k, which means this condition is not satisfied. So now we will have to update the value of our L over here. So now we will get rid of 1x. So because we are getting rid of 1x, the current maximum occurrence we have so far is 2. Okay, now our left is located at this position. Now the length is 5, and the maximum we can make, maximum occurrence is 2. So again 5 minus 2 is still 3, which is greater than k. So again we will have to update the value of our left. So now this time left comes over here, and we will ignore this q, which means the value of q becomes 0. So I'll just remove that entry. Now again this time the length is actually 4 and the maximum occurrence is 2. So 4 minus 2 is still 2, which is actually less than or equal to k. So because this is less than or equal to k, we know that okay, length 4 is can be our answer, but our answer is already 5. So there is no point in updating length to be 4. Okay. Next, what we are going to do is, now this time we will have to update the value r. So when we update the value r, we actually reach to the end of the string, and because we reach to the end of the string, whatever the value we have stored in the answer, we can return it as our answer. So in this case the answer is going to be 5 from this sequence, and we can mention that after doing 2 word replacement, the maximum substring we can make that contains all the same characters inside this given original string is actually of length 5, and that is the solution. If we see the time and space complexity for this one, the time complexity will actually be big O of n, where n is the number of characters that are present inside given s. Now you will think that okay, in order for us to find the maximum occurrence, actually we will have to iterate over this entire array, and it might take like there are 26 entries, so we might have to do this work 26 times. But the thing is, we are actually going to use a clever trick over here. What we are going to do is, at any moment we update our right pointer, at that moment only we are going to update our maximum occurrence, because remember, our maximum occurrence can only increase when we update the value of our right. Whenever we update the value of our left, we essentially decrease the whatever the maximum count we have, which means that our maximum count is never gonna go high. So that's why by using this clever trick, we can actually reduce the time complexity to big O of 26 times n to only big O of n, and you will see it in the coding. Also in terms of space complexity, we can conclude this actually 2 times. We can either conclude this to be big O of 26 because we are storing an array of 26 characters, or we can consider this as big O of 1 or constant space, because this 26 is a finite number. This is not an infinite number. So that is why depends on your interviewer how he wants to treat it, and that way you can take it forward. Now let's move on towards coding now. First of all, we are going to create an integer array to store the occurrences, and we are going to name it as occurrence. Now we will create few variables. So first of all, we will create variable left and right, and we will initialize it to value number 0. Now we will create a variable called answer, and we will initialize it to 0 as well. Also, we will initialize a variable called maximum occurrence. Now we will run a for loop on all the characters of given string. So first of all, we will calculate that whether we need to update the maximum occurrence or not. So now we will check that whether the current substring, if that is valid substring or not. So we are going to use an if condition. First of all, we are going to check that whether the length, so in this case length is going to be right minus left plus 1. So if the length minus whatever the maximum occurrence is, if that is greater than k, which means that if that is greater than k, which means that the current substring is not valid. If that is not valid, we will have to update the value of left variable. And we will also have to decrement the value that is located at current left counter on the given string. Once that is done, for every single update, we will have to check that whether our answer is the longest string or not. So we will check that what is the value of our answer. That should be it. So after this loop ends, basically we should have our answer stored in the answer variable, so we can simply return that. Let's try to run this code. This should have an occurrence. Okay, seems like our solution is working as expected. Let's submit this code. Oh, our solution is not working. Oh, we need to decrement the value first before we update this left pointer. So let's try to run the code again. Okay, let's submit it again. Seems like our solution is working as expected.